Hello, this will be a demonstration of proposition 2 from book 5 of Euclid's Elements, which says that if a first magnitude be the same multiple of a second that a third is of a fourth, and also if a fifth be the same multiple of the second as a sixth is of the fourth, then the first plus the fifth is the same multiple of the second that the third plus the sixth is of the fourth. What this is going to look like is we're going to have two magnitudes, just C and F. We're going to have two sets of equal multiples taken of them. So first, we're going to have AB and DE being equal multiples of C and F respectively. And we're also going to have BG and EH, another set of equal multiples of C and F respectively. What we're going to prove is that AB plus BG, that is AG, and DE plus EH, that is DH, are equal multiples of C and F, respectively. We begin by noting that AB and DE being equal multiples of C and F, what this means is that however many magnitudes equal to C within AB is going to be the same number of magnitudes equal to F within DE, right? That's just by virtue of there being equal multiples, that's what that means. Again, and also by virtue of GB and EH being equal multiples of C and F, then the number of magnitudes equal to C within GB is the same number of magnitudes equal to F within EH. So then if we add these two together, then we can say that the number of magnitudes equal to C within AB plus BG, that is AG, is the same number of magnitudes equal to F within DE plus EH, that is DH, so that AG and DH are equal multiples of C and F respectively. Now this being what we set out to prove, we are done with the proposition, therefore, etc., QED. Now I avoided putting this into more approachable terms, let's say, because I like doing the main demonstrations in the Euclidean terms. But, just to show what this proposition is saying, because it's really quite simple. We're going to have just, again, two magnitudes C and F, and we're going to have AB, and we're going to have DE being equal multiples of them. So let's say like AB equals 3C and DE equals 3F, right? So that AB and DE are equal multiples of C and F respectively, namely triple. And we're also going to have BG and EH being another set of equal multiples of C and F. So let's say that BG is equal to 2C and EH is equal to 2F. So that again, BG and EH are equal multiples of C and F, namely just double. And all this prop is telling us that if we add these together like that, then AB plus BG, which is just AG, is equal to 3 plus 2 is 5, right? And then we have DH, which is DE plus EH, is equal to 5F, right? Again, that's just 3 plus 2. We observe that AG and DH are, again, equal multiples of C and F, namely 5 times. That's all this proposition is basically showing. When you write it out that way, it almost seems self-evident, but it is provable, therefore it must be proven. Now, putting this in more like basic algebraic terms, we might say that like if we have, just some magnitude A like this, and we have some multiples of it, M, A, and NA, then what we're basically saying is that MA plus NA is equal to M plus N times A. Right? Again, that's just the distributive property. But instead of being with magnitudes, right, where the magnitudes can sum up, the multiples sum up, and that's all we're basically doing. So that's all I have to say about this proposition, so I'll end the video here and move on to 5.3.